Hi everyone, this is Gaston with Headwire.com. During my Circuit 2016 talk, I provided some demo code that allowed you to basically search against product data provided by the Best Buy Product API and also demonstrate some real-time indexing using a JMS producer, ActiveMQ as the middleware broker, and then Camel to process that data and send it off to AEM. So what I'd like to do today is go through the setup of that demo code since there wasn't a lot of time during the talk. So the best way to do this is to go to GitHub and visit my project space. It's in the URL. I'll post it along with the video. So the first thing you want to do is download this project. So let's clone this project. And it's a relatively small project. It's a typical AEM project that builds on top of another project that I wrote a couple years ago called AEM Solar Search. Okay, now that we have that checked out, let's go through the README file. The requirements are fairly straightforward. So Java 8, AEM 6.1, I've actually tested it with Service Pack 1 only, so there may be some issues with other versions. Maven 3.2.x for our build tooling, and then I also provide a virtual machine CentOS 7 image for Solar and for ActiveMQ. So both Vagrant and VirtualBox are required if you want to follow along end to end. AEM Solar Search 2.0, this is the platform that we're building on top of so that we get the search interface for free. And then if you want to index products, you will need to register for a Best Buy API key. So let's go through the installation. I already have Vagrant installed, and Vagrant is just a mechanism for defining VM images and provisioning them. So it's foundational tooling you will need to have in place. And then VirtualBox is the virtualization platform of choice, and we'll talk a bit about that later. So you will need to install both. Make sure you have AEM 6.1 author running. I already have mine running in the classic UI. And then as a dependency again, we have to bring in AEM Solar Search 2.0. So let's go ahead and open up another terminal window and clone that. So I'll go up. So git clone. All right, I may have made a mistake in cut and pasting this, so let's do that. Okay, now that we've got it cloned, we'll go into the AEM Solar Search directory and Maven, clean install, and then we have a profile called auto-deploy-all. And what this will do is create an AEM package that has AEM Solar Search and deploy it to the running instance on AEM Author on port 4502. So I'll let that run for a minute. Okay, so that took a little bit of time to run. Now that it's deployed to our AEM 6.1 instance, let's switch back over to the README. Okay, and then the next piece is to provision the demo stack. Again, this has Solar 5 in cloud mode with ActiveMQ, and this is packaged with this application or this project. So we'll move into the demo stack Vagrant project. So I'll need to change out of the AEM Solar Search project and then switch over to the product sample that we'll be working with. And there are a few modules in here. We need to move into the demo stack Vagrant. And for those of you who aren't familiar with Vagrant, it's quite nice. Someone else can define a Vagrant image specification for you with a Vagrant file. And then all you have to do is type in Vagrant space up. And within about 10 minutes or so, we should have a fully provisioned CentOS 7 image running with Solar 5.4.1 running in Solar Cloud mode with an embedded Zookeeper instance, and they'll also have ActiveMQ. You'll also notice on the screen here in the bottom left-hand corner, I've exposed a number of ports to the host operating system, and this is just so that I can actually talk to all the services running on the VM from my OS 10 system. So I'll probably stop this, but it will take, like I said, about 10 minutes depending on your speed. Some of the things that it does do is fully download the tarballs of both Solar and ActiveMQ from the internet, so it'll take some time. Actually, right now you can see that it's also going through and installing all of the OS level dependencies using Yum as the package manager. So again, the goal of providing an image like this and using Vagrant is so that people following along don't need to go and figure out how to get this to work on Windows or OS 10. We've done that by going with CentOS, and then secondly, you don't need to worry about getting JDK8 installed, Solar, Zookeeper, all that. The scripts do document how all of that's done. It's pretty clean. In fact, I probably should take a look, show you that while it's running. So right now you can see it's downloading Solar 5.4.1, but let me show you the scripts. So we switch back over to GitHub and we go into our demo stack Vagrant. You'll notice a few things here. One is the Vagrant file. And in the Vagrant file, for example, I have all of the ports specified. All of these ports are basically what the services provide. So you'll notice we have 3 ports here for Solar. One is the Zookeeper port, the other 2 are for Node 1 and Node 2. And then ActiveMQ has a whole series of ports that we'd like to expose as well. And then further down, we do have a specification for our image. So I've only given it 2 gigs of memory and 2 CPUs. You can change this depending on your needs. And then the real heavy lifting is done by this provision. And I've specified a shell script called bootstrap.sh that does the actual installation. So let's take a look at those. So you can see here, fairly straightforward. We basically just set up some some environment variables and expose them by exporting them. And then we have a couple of scripts that we just run in series. The first one is install Solar, and the other one is install ActiveMQ. These are scripts that I created. They're not real sophisticated. They basically just go in sequence, so there isn't a whole lot of error handling or checking. But for the purpose of a demo, it does help quite a bit. So you can kind of see how you would go about just doing a very basic full installation of Solar just by inspecting and reviewing these scripts. All right, let's go see how our Vagrant provision is working. Okay, and you can see that it's still downloading, so I'm going to pause this demo. Okay, I'm resuming the demo now. The download does take a little bit of time, and the reason for that is, where's the download? I use the Apache archive site, and depending on which mirror I get, it could take anywhere from 30 seconds upwards to about 5 or 6 minutes. The script actually goes through and creates, after the installation, it's just a simple unpack, a move, some symbolic linking, creates users, fixes permissions, and then registers a System 5 startup script so we can start and stop it as a service, and then it attempts to start up Node 1, then start up Node 2, and then it goes through the process of doing a couple of requests to Solar to create a collection for us, upload the config set, and do a couple of other house cleaning. So at that point, it's done. I will note one thing you need to do to have this work with Solar Cloud Mode. You will need to update your host entry on your host operating system with Solar Node 1 and Solar Node 2. I do have that in my host file. I'll just show you here for good measure, and you'll notice right here. And this is just for Zookeeper to work correctly. Zookeeper does need to know of the nodes by name. And then after that, you can see that we've gone through the ActiveMQ installation. After this is done, we can validate the install pretty easily. The first thing to do is to go to localhost 8983, which is the first Solar node. And you can see here that we have a movies collection, and we have basically our two nodes here. We have a couple of shards. I've split the index into two shards. And then the other piece of the stack is ActiveMQ. It'll be providing our message broker for the integration for us. So let's take a look and go to 8161/admin. And the username and password is admin. And if you get to our topics, you notice we don't have any that we have created yet. So these are the first two things to check, just to make sure you have Solar and ActiveMQ running. Okay, so let's go back to our README. Okay, so we've gone through and we've done step 5, which is the provisioning. Now let's actually go and deploy the product demo. And again, this is another AEM style project. So I'll have to go up one level. And for those of you familiar with AEM development and the Adobe Maven archetype, you'll notice it has core, the integration tests, and the UI submodules. So fairly straightforward. So assuming you have most of the Maven dependencies already, this build should take about 15 or 20 seconds at most. Okay, so now that that's done, let's just do a quick check and make sure that we have all of our bundles running. So I'm just going to go into the Felix console on AEM. And we'll just do a quick check just to make sure that everything's active. So it is. We can also sort by ID here, and you can see that we have our AEM Solar Search product sample. It's active. Okay, the next thing to do, given that we're building on top of AEM Solar Search, and I think out of the box it's designed to work with a Solar master, single master setup, we do need to go into Felix console and modify the AEM Solar Search configuration. And we're going to do three things. One is we need to make sure we define a new allowed request handler so we can perform our queries. Second, we want to make sure that we're in Solar Cloud mode. And then the third thing, to make the client-side piece work, we need to make sure that we have one of the nodes marked as master. We'll use 8983. So the easiest way to do this is go back to Felix, select configuration, and I typically search for AEM Solar, and our configuration service comes up pretty quickly. Okay, so the first thing we want to do is add a request handler. It's movies. We want to change the mode to Solar Cloud, and then the master, we want to change that to 8983. And then Zookeeper is on 9983, so no changes are required there. But this is the configuration you'll want, and we'll save that. Okay, before we jump into indexing, actually let's start a little bit backwards. Let's start with the AEM indexing first. I wasn't planning on it, but let's try it. So we'll go into AEM, websites. We do have a sample site set up already with the search page. So I'm just going to create one sample here, and we'll call this Demo 1. And let's open up our search page and see if anything was indexed. Okay, we may have a small issue here. I'm going to pause the demo just to take a quick look. Okay, I did get a bit ahead of myself. We did submit a job for indexing, but what I failed to do was actually turn on our Apache Camel piece that's responsible for picking up our document. So let's take another step back here. So what we've done with this integration is essentially allow AEM to listen for page modifications, create a document model in the form of a hash map, and basically use a JMS producer to send that request off to ActiveMQ. And then we have a secondary stack, which is our ETL solution, or our document processing solution, which is built on Camel, which will read off of that topic, perform some processing, and then index Solr. So the first thing I want to show you at the top is let's inspect the logs to see this eventing in action. And then on the bottom, we actually have to start our Camel piece. So within the same project, AEM Solr Search Product Demo, we have a couple of projects. One is Camel AEM to Solr, and this is the piece that will basically have a long pull and act as a JMS consumer. There are a couple of there's a wrapper shell script called runsh that really just runs our Camel application. So there's a main method called AEM to Solr routes. But for this demo, really all you need to do is run the shell script. It'll compile all the Camel code and basically start to have listen for those messages. Okay, and we can see that the Camel route has started. And then we have our logs for AEM at the top. So let's go ahead now and let's create a new page. I'm going to call this ad hoc demo 2. Okay, now if we switch back over to logs, if everything works correctly, at the top you'll notice in AEM that there was the JMS index listener was triggered. It noticed that it was an addition to the JCR, so it's going to say this is an index add operation, and then we create a very simple data model in the form of a hash map. You can see, for example, that the hash map keys are all prefixed with AEM dot some notation. And here we've done or opted for a model where it's AEM dot field dot something represents a field. So in this case, we have our URL. So you can see this was the page I just created. The AEM.op, this is some piece of metadata that will tell Camel what type of Solr indexing operation to perform. In our case, it's an add. And then we have a description, which is not set since we haven't set it. We have the name, which is the name we created, and then the CRX path and ID are the same. And then it sends it off to our message broker, ActiveMQ. Then on the bottom, you can actually see that Camel is reading off of the JMS topic and that it's converting that hash map into a format that the Camel Solr component is expecting. So they use a similar notation as us. We're using AEM.field. They use solrfield dot the field name. So a couple things to note here. When we go back to our ActiveMQ, you'll notice here we have a new topic called AEM index. So AEM is sending messages here, and Camel's acting as a JMS consumer reading off of this topic. And if we go into our Solr backend and do a query, we see our document as well. We should also be able to go to our front end and just refresh this page. And you'll notice we have our document there and a content source attached. So let's do a few other tests before we move on to the product piece. So let me create another one here. So we'll do new page, and we'll call this one ad hoc demo 3. We'll also create some child pages under the first one, the demo 2. And I'm just going to call this one demo 2 child 1. And another one, and we'll call this one demo 2 child 2. So while we've been creating all of these nodes, we're actually triggering messages. So if we go back to our terminals, again, you can kind of see that we're both sending messages as the JMS producer from the top and reading them on the bottom. So we should now see about four messages here, four documents indexed within AEM. And then again, if we go back to our example here, we get all four. What's nice when you're doing indexing within AEM, we basically need to follow the hierarchical model that AEM imposes, so cascading deletes. So a good example here is that we have, in this hierarchy, we have demo 2, demo 3, and then underneath demo 2 we have 3. So if we were to delete demo 2, we would expect 3 documents to be removed. So let's clear our windows real quickly, and let's see what a delete, specifically cascading deletes, looks like. Okay. So in this scenario, we've detected that it's a delete operation, and we're now setting the AEM op to delete doc. And the only field we need to set in our hash map this time to represent our document is just the field ID. And then on the camel side, it notes that it is a delete operation and that it's going to basically perform a delete by query using CRX path and then this path. The reason why this works is because we've tokenized the CRX path to use a path hierarchy tokenizer. So that basically means that every path is tokenized successively. So it'll be content or content AEM Solar Search product sample. Third token will be content AEM Solar Search product sample, EN, etc. So when I specify a path that is 4 levels deep like this, it'll actually bring back as part of the query all of its children. So this is why we call this one a delete by query. So when we go into our front end and I remove this filter, we now just have the one AEM page that we index that is not part of that hierarchy that we deleted. Okay. Let's see. Let's move on to the product side of the demo. So I'm going to kill or stop camel. One thing to note on that is that once you start camel one time, it'll register itself as a durable subscriber to the message broker. So I can continue to send messages to AEM. Actually, let's test that now. So for example, I'll call this one just camel 1, camel 2, and we'll just do one more, camel 3. So the JMS listener is still running an AEM. It's still sending messages off to ActiveMQ. But you notice that we've got some messages in-queued here at the bottom, but they're not all read. And again, if you go back to Solar or to our search front end, you'll notice that we still only have that one document. Well, that's because the JMS consumer, in our case Camel, is down, which is fine. This is part of the architecture. We like the ability to decouple these services so that we can have Camel down, so we can do some maintenance, but Solar and ActiveMQ are still running, and there's really no impact across systems. So in this scenario, if I rerun or start up Camel again, it will notice that there are 3 messages that have been in-queued, and you can see here it has actually pulled off the first message, the second one, and the third. So now if we go back and remove this facet, we get camel 1, 2, 3. So little tangent there. Okay. So now let's go ahead and work through the last piece. It should be described in the README as well. We talk about product indexing. The product indexing is part of the Camel Products to Solar README. So let's jump in over there. And the one thing to note about this one is that we're using the Best Buy product API, so you do need to register for an API key. And once you do get a key, you will need to edit this path and provide your key. And then similar to before, just start Camel, and what it'll do is it'll pull down and fetch, I think, a 2 gigabyte zip file of all of the Best Buy movies, and then use Camel to unpack, parse the JSON files, do some transformation, and then push it into Solar. So let's go ahead and go through that process. So we want to get out of the Camel AM to Solar, and we want to change into the Camel products to Solar. Okay. It would help if I could type. So I'm going to go ahead and edit movies.properties. If you're using the Vagrant VM, the Solar host, port, collection, and Zookeeper host are all correct. All you need to go in is in here and change your API key after you register for it. And I'm going to take this one off screen and add my host key. Okay, so I've updated my host key. If I look in Git, you'll notice that mine has changed, so I won't check this back in, of course. And then I'm going to go ahead and just run this. And it follows the same pattern as the AM one. What this one will do, basically, is initialize all of the Camel routes, go through the process of pulling in the products. There are well over 100,000 products, so this could take some time. We're probably not going to wait for all of them to go through, but we will wait for the download to complete and wait for products to come back. So while we're going through that, I kind of want to walk through what I went through in my presentation, and it's what these routes look like. So let's first start with the Camel AM to Solar. And our main entry point is really just a simple Java standalone application. And again, you can embed Camel however you want, and that's one of the appeals. I am using the main wrapper that the Camel community provides. It's a nice way to be able to essentially run it standalone, be able to exit by hitting just Control-C. It's a very convenient way. But really the heavy lifting is done by the routes that we configure. And you'll notice my first route that's defined is using ActiveMQ as a consumer. It'll look for the topic. We have property definitions in place so that we can pass in the topic. Okay, so we have the topic configured as a consumer. You'll notice here it's also set as a durable subscription, and this allows us to stop after the first time Camel and allow the JMS messages to continue to be written to that topic, and then when Camel's available again, it can pick up those messages for processing. Then we use a content-based router using the simple expression language, and it's pretty simple. Since we're using a simple hash map, we can actually access the Camel message, the body, and we can pull out by property key in the hash map some value. So in this case, the AM operation, if it's equal to add doc, then we want to direct the message flow or the exchange to another route called Solar add. And then we do the same thing for delete. It'll end up hitting the delete route. For the add, we do a few things. One, we convert the JMS document hash map into a Solar representation. And really all this requires is that we convert the property keys and convert them to another set of keys that we set on the message header. And the Solar component in Camel describes that format. We also have an enrichment step here. There's a file packaged with this sample called analytics.txt. And if you essentially name your pages within AM a certain way, it'll attach to it some analytics page view data. So it's just a neat way to demonstrate within Camel how you can enrich documents and merge other data points prior to indexing. And then we set our operation to be insert. You also notice that we had some facets that describe the content source. Here we're just hard coding a field called source with the value AEM. So it's effectively what you see when you're here. So again, another example of how you can augment the source outside of AEM or your source system. Okay, so what I'd like to do now is jump back. Again, you can look at my other talk and the PowerPoint deck. I kind of go through this. But the bottom line is that these routes are very simple and very easy to read. You can even hand this off to a business analyst and they could pretty much tell what you're doing as part of your indexing process. Okay, so at the bottom here we have our product running. There is no output running. There are too many products for me to out all those messages. So take my word for it. It is processing on the back end. If you don't like the way that works, just change the code to to add some debug level messages and change the properties file or the log4j properties file. So let's see if we have any messages. And we do. So right now you can see we have approximately 27,000 movies indexed. As part of this work here, I've indexed ratings, the formats. You can drill into these. So if you want like the Blu-ray discs and you want PG-13, and then by cast and crew, let's say Matt Damon, we'll get the Bourne series, for example. And you can click through these, and there's a very small dynamic product detail page I've created in this sample, just to give you an idea of how you can actually have a product data set fully put into your search backend. It never goes into AEM. All AEM does is own the glass. And the way that works is, for example, this product detail page uses a selector where we pass in the product ID, and then on the back end it makes a search call to Solr to bring back the teaser here, the name, the specifications, cast information, crew information. So kind of cool. And we can also do the same thing. We can just type in Bourne here, do a search, and do a full text search across this, and we're going to get all the Jason Bourne movies. And again, I'll remove this. You'll notice that it's slowly indexing everything. It's going through well over 100,000. Just to round things out, I like Star Trek. And let's maybe click through on Star Trek Insurrection, and we'll show off, again, its product detail page. And then you'll also notice we get recommended movies on the bottom. This is actually using the More Like This handler within Solr, and all it does is basically extract, look at the document vectors within this double feature, this actual item, and then does a calculates how close using document vectors other types of content are to it. So poor man's way of doing some recommendations using an item-based recommendations approach. At any rate, I hope you guys liked this demo. Like I said, there's a whole lot in here that we did not discuss, but hopefully you find value, and we'll find this as a concrete example of how to build an application on top of AEM Solr Search. And for those of you who aren't familiar, this demo was built on top of AEM Solr Search, which is available at aemsolrsearch.com. We actually have more videos that are more introduction to this free platform, and then also it's available within GitHub. And this was the piece that we installed earlier in the process. So again, feel free to take this, play with it, break it, have fun with it. Until next time, guys, thank you.